Welcome guys, let's solve another LeetCode daily challenge. Determine if two strings are close. Two strings are considered close if you can obtain one from the other using the following operations. Operation 1. Swap any two existing characters. For example, we have a string A, B, C, D, E, and we're getting A, E, C, D, B. In this case, we have swapped B and E. Operation 2. Transform every occurrence of one existing character into another existing character and do the same with the other character. For example, we have a string AA, CA, BB, and we are getting BB, C, BAA. In this example, we have transformed the first A's into B's and did the same thing with the last B's. We have transformed B's into A's. And you can use the operations on either string as many times as necessary. Given two strings, word 1 and word 2, return true if word 1 and word 2 are close, and false otherwise. Some examples and try to come up with the solution, the algorithm. Let's start discussing this example. We have two strings ABC and BCA. I want to do the following. I want to apply swapping. I want to swap A and C. I'll get CBA. And next, I want to swap B and C right here. Next, we will get BCA. And this string is the same as this one. As you can see, they are close. Let's switch into discussing a bit more difficult example because words are longer. That's why it will be a bit difficult. See. I want to apply swapping right here. I want to swap these two. We'll get B, A, B. And this is the same as this one. Next, we have double Z in C. This substring is also the same. And I will reach here at the end of both words, A and Z. And since they are not the same, we can apply some operation. For example, let's swap to get A here. We can swap Z and A, but if we put here that, we are breaking the whole chain. The whole chain of checks that we have made to reach the end. That's why this is not the best approach, because if we apply swapping right here, when we are at the end of the string, we have to start the process of checking the strings from the start. This will just throw us into the beginning. That's why tracking how many swapping or transformation we have made is not the same. Is not the best approach, because this algorithm approach, it will be really difficult to implement or just even think about, because we'll just reach the end and go back to start from the beginning. That's why this is not the best approach. I want to suggest another approach, more primitive and simple. I want to count how many occurrences all these charts have. I'll explain what I mean. Let's count. See here, this string has 3 occurrences of X. One, only one occurrence, and A has 3 occurrences. And this one, X has 3 occurrences and A has 1 occurrence. See, the most important part here, I want to check that these keys of this map are the same. If they are not the same, the strings are not closed. If they are the same, I'll check the following, that these occurrences are the same. 1, 3 and 3, 1. They must be the same. Otherwise, the strings will be won't be close. I'll explain what I mean. See, here we can transform all these A's into X. 3 A's will 3 A's will turn into 1X, and 1X will turn into 3X. I will get a x x x. I mean, see, I just applied here. Yeah, if they are the same, it means that we can apply some operations. I don't know how many. If they are the same, these occurrences are the same as this one, and the keys are the same. We can attain this string from this one, as we did right here. We got 3x and a. This string is the same as this one. That's why this approach is very simple and it works. Let's jump into coding this solution. First of all, I want to change these namings because I don't like digits in the variable name. I'll at least name as word1, word1, and word2. First of all, I want to turn this string into map. Grouping by it, h count, word2, grouping by it, h count. It will return a map of word1 map. Well, this will return a map where the key is the char and the value is the occurrence, its occurrence. Word1 map. Sorry. They must be 2. And first of all, I want to check that the keys are the same. Keys, if they are not the same, return false. And next I want to construct a queue, priority queue, because I want to iterate over all these values, and priority queue provides sorted list, the sorted order, and here I want to pass word1 map all values, and I'll call it q1. This will be q2 word2 map. Repeat q1 size, and if q1 poll is not the same as q2 poll, then we return false, because if they're not the same, they cannot be attained, and we are returning true here. And let's take this solution and submit here. Let's see whether it works. I hope this will work. And see, the solution was accepted, and the runtime and memory were pretty efficient, because runtime beats 80% and memory beats 97% of users with Kotlin. And talking about the complexity of the algorithm, and well, for constructing these two maps, we'll spend on, because on plus, and for constructing priority queue, we'll spend on log n, and and here if you are repeating this, there is a loop of queue size and one loop, and overall time complexity will be O log n log n log n. This is time complexity, And speaking about the memory complexity, here we are storing two maps, and the map are of limited size because the size will be only 26 because there are only 26 letters in English alphabet, and the cues will also be of size 26. That's why the memory complexity will be constant. Well, this is the end of this tutorial. I hope you learned something new. If it was interesting, please like and subscribe, and see you in the next videos.